Established in 1850, the University of Sydney is Australia's first university. We think of Sydney as first amongst Australia's universities in many regards, and in particular, materials is in our target right now.
We have one of the best research environment for material research in Sydney University. We have world-class material scientists in the University of Sydney.
As a researcher, that's what I'm looking for. You want something freedom thinking, and on the other hand, you need the facilities and knowledge to support you.
Within the materials and structures cluster, one of the key drivers is sustainability, which is an area that I work in. Sustainability in terms of real-world applications for materials in the areas of alternative energies, fuel cells, rechargeable batteries, things like that. The reason I come to Sydney University every day is the ability to not only fundamentally study a material, but to develop it into a real-world application, and to develop those applications for the benefit of the world.
The University of Sydney is a really excellent place for me to be able to do my research because I have access to world-leading facilities that can allow me to do really detailed characterisation. My research really depends on being able to get very, very high quality new information and ask new questions through new characterisation techniques.
Sydney is headquarters to the Australian Microscopy Microanalysis research facility. This is a fantastic national facility with all kinds of electron microscopes, atom probes, and various other kinds of tools that let us take a journey into the inner space of materials and see how they work.
An alloy, we simply take an existing alloy with a known composition and squish it down to make a nanocrystalline version. So the problem with that is that if you have an element that you've added for a particular reason to that alloy, and that species goes and sits at the grain boundaries and you have so many grain boundaries, then you can end up with that species not being available to play the role that it was supposed to play in that alloy. So we really need to understand what the solutes are doing at the grain boundaries in order to better design nanocrystalline alloys.
Materials engineering is really a fusion between the questions on how you process and make materials, how you look inside them and see how they work with microscopes and characterisation type techniques, and of course the modelling and the calculations that we do in trying to predict structure-property relationships.
We test structural components, so they might be part of houses, they might be part of a bridge structure, they might be part of a high-rise building, but we also analyse structures, we create computer models of structures, and through these models we are able to simulate loads on structures, and we can then predict the response of the structures, and we can design them for strength. We work with the other members of the materials and structures research cluster from the point of view of sourcing detailed information about materials themselves. So it's a partnership that can model and utilise the knowledge at both levels.
There's a great deal of enthusiasm around the idea of the Materials and Structures Research Cluster. People really love the idea of looking at what their colleagues are doing from other schools, looking at what people are doing in different disciplines, and figuring out ways that they can add value to what others are doing, and indeed extracting value from the broader community.
I think we have a really collegiate and collaborative work environment here. Our materials researchers are spread across physics and aerospace, mechanical, mechatronic engineering, civil engineering, and that forces us to work in a very collaborative and cross-disciplinary, multidisciplinary way.
We're working on biodegradable materials for putting into the body for regenerating lost or damaged tissue, and we specialise in the area of skin and cartilage. Scaffolds, which when implanted in the body, turn into skin or turn into cartilage in a matter of a few weeks or months. And we're leading the world in the area of developing scaffolds for regenerating diabetic ulcers. This is a very interdisciplinary activity. In fact, a lot of our collaborators are from the Faculty of Medicine. As well as that, there are the experts who work in the microscopy area that we work with. Again, microscopy is a very advanced discipline, and we work very closely with the microscopy unit as well. Everyone here is doing something new and exciting. We're all on a cutting edge somewhere, and all of us are working hard in that cutting edge research, and yet There's a unifying synergy amongst all of us.
The emergence of a huge middle class in Asia is going to drive all kinds of new demand. Demand for energy, demand for food, demand for water. And the people who are going to deliver in that space are engineers. And a lot of the solutions that we need to create are materials and structures solutions.